Now let's look into the special type of normal distribution. What is that special? Let's see. So it's called the standard normal or G distribution. So a standard normal distribution is one in which the units on the x-axis are expressed in terms of standard deviations away from the mean. To compare data to a standard normal distribution, you subtract the mean and then divide by the standard deviation, and this is called normalization or standardization. We normally call this as a standardization. This technique of G-score standardization, we have done it in descriptive statistics, okay, data transformation. In that section we have done. If you want to know more about that, you can visit my descriptive statistics course, and then in that you can watch it. Okay, but the concept of comparing data to a standard normal distribution, you will subtract the mean and then divide by the standard deviation, and this is called standardization. Thus note that standardization in this sense is unrelated to database record standardization. The transformed value is termed G-score, and the normal distribution is sometimes called the G distribution also. So this is our normal distribution, correct? Now the standard normal distribution is a normal distribution with a mean of 0 and a standard deviation of 1. It is also known as the G distribution or the standard Gaussian distribution. So how it was converted? If you see, this is till here it is normal distribution. After that, by applying this formula, see that after applying the G-score, after converting a mean into 0, mean will become 0, and standard deviation, no more 1 sigma, 2 sigma, 3 sigma, no more 1 standard deviation, 2 standard deviation, or 3 standard deviation. This will be converted into the 1. Then how it will be transformed, I'll show you. Yeah, this is your standard normal distribution. You will not find mu, and you will not find standard deviation. You will find only values 0, 1, 2, 3, -1, -2, -3, and these are known as G scores. G scores. So I'll show it again one more time. Till here, this is your normal distribution curve that we have seen before. When I convert this mean into 0 and standard deviation into 1, this is what this -3 will be replaced with -3 sigma will be replaced with -3, -2 sigma will be replaced with -2, -1 sigma will be replaced with -1, and it will end up becoming like this, and this is what we call it as a standard normal or G distribution or standard Gaussian distribution, whichever the name you can call it. It's like Krishna, you can call Madhava, you can call Keshava. At the end of the day, it goes to Krishna. That's okay. So this is what we call it as a standard normal distribution, as a probability density function, and this is how it looks. It's is equals to f of x is equals to 1 and square root of 2 pi multiplied by e power minus of x square divided by 2. So here x is the random variable that can take on any real value. If you don't know what is a random value, just visit my course Intuitive Probability for You. In that, I have clearly explained about the random variable. Next, the standard normal distribution is important in statistics because it can be used to convert any normal distribution which any normal distribution into a standard normal distribution or G distribution, which simplifies many statistical calculations. To do this, we use this formula. Of course, you may know about this formula because we have used it before also in standardization and data transformation in descriptive statistics. So Z is equals to x minus mu whole divided by sigma, where Z is the standard score or G score. Normally, widely you call it as we call it as a G score. Z is G score. Then X is the value that we want to convert, and mu is the mean of the original distribution, and finally sigma is the standard deviation of the original distribution. So the G-score represents the number of standard deviations that a value x is from the mean of the original distribution. The G-score is positive. It means that the value is above the mean. If it is negative, it means that the value is below the mean. The standard normal distribution is widely used in statistical analysis, hypothesis testing, and quality control, among other fields. Many statistical tables and software packages provide information about the standard normal distribution. It's also called as a G distribution, such as the probability of a value falling within a certain range or the critical value for a given significance level. So now let's look into the G distribution curve. So this is the third party application. You can also basically look into this if you want. This is the URL. So first, let's look into the standard normal distribution curve. Then we will get into the table. So if you see this, let me put it 0 to Z, and this is our standard normal distribution curve. So in spite of mean mu, you have 0 and all 1 standard deviation, 2 standard deviation, 3 standard deviations has been replaced with 1, 2, 3 positive, -1, -2, -3 negative. Okay. So these are no more standard deviations. These are G scores. Whatever you have is G score. This is G score 0. This is G score 1. This is G score -1. This is G score -2. This is -2 and G score -3, and in between also you will have a G score of 1, 0.001, 0.302, 0.405, 1.1.009, 1.09, 1.209, 1.309, 1.109. You'll have multiple values G scores here, because this is all obviously these are all continuous variable. Okay, so now let me put from 0 to Z. I want to see from 0 to Z either a positive side or negative side. Okay, I'll go from 0 to Z from positive side. You see that 26.73% of probability, and if your G score is 1, let me put it exactly, G score is 1. If it is 1, 34.13% of probability of happening. Then I'll increase down my G score to 0.05. It's 47.98%. And if it is 3 point, okay, let me go here, 2.93, 49.83%. And 3.4, 3.59, it's 49.98%. Similarly, if I go negative side, if my G score value If I get it in negative side minus 1.01, still my probability 34.8 percentage, 34.38 percentage. If it is minus 2, my G score, my probability is 47.72 percentage, and minus 3 is 49.87 percentage. This is from 0 going left side and going right side, and other ways up to Z. So we'll start from somewhere minus 3, then we'll keep on going till the first plus 3. Of course, this is at, you have the tail more, okay? So minus 3.01, this is the core score, and then this is exactly I'm getting the 0 score. I think yeah, 0, yeah, 0.1. So 53.98 percentage. Then 1 from G up to Z. See, I started from left to right. Okay, left to right. So that's why it will calculate everything. So that is also very important when you're taking G scores. Okay, 1.03, 84.85 percentage. Then 3, 2.98, 99.86 percentage. Now let me go for the Z onwards. So somewhere we started from here. So let me start from this side. This is the Z. From here I started from this side. Again, this is 3, 0.21 percentage, 1, 15.62, 53.8, and 97.72 percentage. And that's it. This is how you take. You can take 0 to Z, either 0 to Z this way, or from here to here, or from this side to this side. From this side to this side. So this is what the standard normal distribution, and this is some kind of simulation for you to understand much more about this G score. So now let's look into this. It's how you can calculate. So this table, this is very important. You can also use this table. The table shows the area from 0 to Z. That's okay. Instead of long table, this is very important, this point. Long table, they have put 0.1s running down. 0.1s are running down here. Then 0.01s are running along here. So example of how to use this below is here. For example, start at the row for 0.4. So 0.4 is here. Yep, this is my 0.4 now, and the read along until 0.45 there is a value. Okay, I'll just go 0.45, and this is the value. So for me 0.4 plus 0.05, it will become 0.45, and the probability of getting that would be 0.1736. You say that it's 17.36 percentage. So 17.36 percentage of the population are between 0 and 0.45. If you want to see that, let me come here 0 to 0, and then 0, 0.19, 0.35, 0.45. Just a minute. Let me put it 0.45. Yeah, yeah. Okay, that's okay. 0.46, 17.36 percentage. Yeah, I got 0.45. It's closer. So 0.45 is 17.36 percentage. And that's how you calculate how much of data that lies between respective values. And second example, because the curve is symmetrical, the same table can be used for values along either direction. So negative 0.45 also. Even if you want to say the negative 0.45, 0 to 0 point negative 0 to negative 0.45, the value would become same. It won't change much. Okay, that's how you can use these values. So if you want minus 1 is this 34.13, absolutely correct. If you want minus 1.9, then it's 36.21 percentage, and 3.0, 49.9 percentage. So this much of data lies in between this respective G scores. So basically G score tells how much of data lies in between two of their G scores. You can't take one G score, you have to take an interval of G score. Either 0 to 2, or minus 1 to 1, or minus 2 to 2, minus 3 to 3. So minus 2 to minus, sorry, yeah, minus minus 2 to plus 2 is your 95 percentage interval, and minus 3 to plus 3 is your 99 percentage interval. Like that you take, and when we say 95 percentage interval, obviously 95 percentage of data lies in between this. That's what is a small simulation for you to understand the standard normal or G distribution better. And one thing you should always remember, normal distribution is not same as standard normal distribution. Both are not same.